Exercise 8.3 of the Mathematical Methods by S.M. Yusuf. Question number 11 till question number 16. Apply the Cauchy's root test to determine whether the given series are converging or diverging. Now the question arises here that what is the Cauchy test? Cauchy's, it can also be called as Cauchy's root test. That is given on page number 352. In that test, the given series be a positive terms and you have applied the limit on that an term that is in your series an raised to power 1 over n. In the Cauchy's root test, you have to take the power of that an as 1 over n and apply the limit n approaches to infinity on that. And you will get some answer here. If this answer is less than 1, then this means your given series is converging. And if this answer is greater than 1 or infinity, then the given series is diverges. And if it is equals to 1, then this test fails and you have to move on some other test. So let's start from this question number 11 of this exercise using the Cauchy's root test. In the Cauchy's root test, basically you have to apply the limit on an and you have to apply the power 1 over n. So if you observe, you have to apply the power 1 over n and then apply the limit. For that purpose, on which questions you can apply the Cauchy's root test? The questions in which the an term have the power n. Then you can easily figure out that you can use the Cauchy's root test here. Because that an has the already power n, and if you apply the power 1 over n on that n and that n can be cancelled out. And it will be easier to solve that questions. So this is a hint that you can use the Cauchy's root test here because it has already the power n, and if you multiply it with 1 over n and n can be cancelled out and your term an will be simplified one and it will be easier to apply the limit on it. So let's start the question 11. Your an is an equals 3n plus 2 divided by 2n minus 1 raised to power n. Now limit n approaches to infinity, an raised to power 1 over n. This will be equals to, this is your Cauchy's root test. This is equals to limit n approaches to infinity, an term is 3n plus 2 divided by 2n minus 1 raised to power n, and this formula power 1 over n here. N and n can be cancelled out. So you will be left with limit n approaches to infinity 3n plus 2 divided by 2n minus 1 here. Now take n common to apply the limit. This will become 3 plus 2 over n divided with, take n common from here as well, 2 minus 1 over n here. This one and this one will be cancelled out. Apply the limit here. Limit n approaches to infinity 3 plus 2 over n divided by 2 minus 1 over n. This term will goes to 0 after applying the limit in this term. So you will get here 3 over 2 in your answer. And this is greater than 1. So the given series diverges by the Cauchy's root test. Question number 12. Summation 1 to infinity 1 over n raised to power n. Your an term is 1 over n raised to power n. Limit n approaches to infinity, an raised to power 1 over n will give you limit n approaches to infinity. What is your an? You have n raised to power n and whole power 1 over n. This n and this n can be cancelled out. So you will get here limit n approaches to infinity 1 over n, and that is equals to 0, and 0 is less than 1. So it means the series converges by using the Cauchy's root test. An term is n over 10 raised to power n, and limit n approaches to infinity, an whole power 1 over n will give you limit n approaches to infinity, n over 10 raised to power n and whole power formula power 1 over n. This n multiplied by 1 over n will cancel out. You will get here limit n approaches to infinity, n over 10. And this cannot be further simplified, so apply the limit here. You will get here undefined answer. So the series diverges by using the Cauchy's root test. An equals n over 1 plus n cube whole raised to power n. Limit n approaches to infinity a n raised to power 1 over n. This will give you limit n approaches to infinity n over 1 plus n cube raised to power n and whole raised to power 1 over n. This n and n can be cancelled out, and you can write it like limit n approaches to infinity n over 1 plus n cube. Now you need to simplify it. The highest power in the denominator is n cube. Take it common. And if you take n cube common from here, you will get here 1 over n square. Divided by n cube common here, so you will get 1 over n cube plus 1. This n cube and n cube will be cancelled out. Apply the limit n approaches to infinity. This term will goes to 0, this term will goes to 0 or something will give you 0. And 0 is less than 1, so it means the given series converges by using the Cauchy's root test. An term here is this one, and that is 3 raised to power n over n cube. And after applying the Cauchy's root test, that is limit n approaches to infinity, an raised to power 1 over n will give you limit n approaches to infinity 3 raised to power n over n cube and whole raised to power 1 over n. This will give you limit n approaches to infinity 3 raised to power n whole raised to power 1 over n and n cube raised to power 1 over n like this. It can be separated like this. So this one will be limit n approaches to infinity 3 over n raised to power 3 over n like this, because this n and n will be cancelled out. Now it can be written as limit n approaches to infinity 3 over n raised to power 1 over n whole cube. Now you know that limit n approaches to infinity, n raised to power 1 over n will always give you 1 in your answer. So it will become 3 over 1 whole cube. So it will become 3 that is greater than 1. So it means the given series diverges by using the Cauchy's root test. Now move on to question number 16. The an term here is an equals n into pi over n raised to power n. Now use the Cauchy's root test, that is limit n approaches to infinity an whole power 1 over n. That will be limit n approaches to infinity n into pi over n whole power n, and this whole power as 1 over n, the formula power. Now separate the powers into the functions as if they are multiplying with each other. It can be written as limit n approaches to infinity n raised to power 1 over n and pi over n into 1 over n. This can be cancelled out, and you will be left with limit n approaches to infinity n raised to power 1 over n into pi over n. It can be written as, if you apply the limit here, this term will give you the answer 1, that is the direct, you can just directly write it 1 here, into pi over infinity will give you 0 here. So you will get in your answer as 0, and 0 is less than 1. So this means the given series converges. The given series converges by using the Cauchy's root test here.